Good morning, students. Welcome back to science class on the chapter light. Uh, uh, in the previous classes video was uploaded only 10 or 12 minutes. Okay, so due to technical problem, uh, today I'm repeating that same concept. Okay. Yes. So now we are in the. So today we are going to discuss the last topic of light chapter. Okay. All the lenses are different. Means the focal lengths of lenses may different, or we can say that the converging and the diverging point of lenses may not equal. Okay. Why? Because some lenses are very small, some lenses are thin, some lenses are thick. So like that. So that's why the focal lengths of those lenses may different. So due to the different in focal length, the converging and diverging point of lenses also different. For example, say now I'm taking this is seat. Okay, here. Just imagine some rays parallel to principal axis. Those rays are meeting at f2. Okay, those rays are meeting at f2. Okay, so now I will take one more lens. See. Okay, yes. See here. So now, see now both are what convex lens, and this one is thinner and this one is thick lens. Okay. So observe here. Here the converging point is little bit far from the lens compared to this one. Here the converging point is very close to the lens. Okay. So now see what are the difference here. Here difference is here focal length is little bit far and here shorter focal length. Okay, the converging point is very close to the convex lens, and the diverging here also converging point is here converging point is little bit far compared to this one. Okay, so now we can achieve this one by introducing the one more quantity, that is power. Okay, power. So power. So now here we can say that the power of this lens is greater than this lens. Okay. So here now see here the converging point is little bit far, and here converging point is very close to the convex lens. So here we can say that this power has more power. Okay, why? Because the converging capacity of this lens is more than this one. Okay, see the power means the ability of a lens converge or diverge light rays depends on its focal length, or we can say that the degree of convergence or divergence of light rays achieved by a lens expressed in terms of its power. Okay. Okay, see it. So we can write the total power. We have formula that is 1 by f. So power of a lens means this is the reciprocal of its focal length. Okay, so reciprocal of the lens is known as power of a lens. Okay, see actual power means here. See here. Now here the focal length is very short, right? Correct. Here now these rays are bending with large angles. Okay, these rays are bending with large angles. But what about thin lens? So here the rays are bending with see here the angles are here the rays are bending with larger angles, but here the rays are bending with shorter angles. Okay, so now here this lens, it has more capacity to bend the rays, okay, to bend the rays with the larger angles. So now this lens, it has less capacity to bend the rays with the shorter angles. Okay, so that's why we can say that this lens has more power. If the focal length is shorter, then we can say that power increases. For example, here focal length is more, here focal length is more, and here focal length is less. Okay, here focal length is less, so we can say that this lens has more power than this one. Okay, so here, and we measure, we measure focal length in meter. We measure focal length in meter. So that's why this is m. Okay, then the SI unit of power is, see here, now this is 1 by m. Okay, the SI unit of power is m to the power minus 1, because it was upper side, right? Okay, the power of lens, that is m to the power minus 1. Okay, so instead of this m to the power minus 1, we use capital D. Okay, this capital D is the SI unit of power. Here D means diopter. Okay, for example, say one diopter, two diopter, three diopter, four diopter, like that. Here one diopter is equal to 1 m to the power minus 1. Okay, so 1 diopter is equals to 1 m to the power minus 1. Okay, we use this same formula for all the lenses. Okay, we use this formula for all the lenses, whether it is concave or convex. This is concave, right? P equal to 1 by f. So this is convex, and this is concave. Here also P is equals to 1 by f. But we will take focal length of the convex lens. Concave lens has a minus, right? So that's why this is minus. Okay. If the power, if it is in positive, then see, for example, the power is 2D. 2D means 2 diopter. So here this sign which indicates the lens. If see the focal length of the convex lens is, we'll write focal length of a convex lens in positive, right? So now this is plus 2D. So which means here the lens is convex. Suppose if it is minus 2D, if it is minus 2D, okay, so then clearly we can say that this minus sign which represents the concave lens. If it is positive, then it is convex. If it is negative, then it is concave. Okay. Yes. So power of lens means it is the reciprocal of the lens. Okay, some people they are suffering from myopia and hypermetropia. So we'll learn in the next class detail. Hypermetropia and myopia. Okay. See here, see at that time, we can't use a lens at a time. Sometimes we have to use more than one. Okay, to defect those corrections. Okay, for example, see. Sometimes I use two lenses like this. Okay, see here I'm using two lenses. One is convex and another one is concave. Okay, sometimes we have to use two lenses. So here how to calculate the power? So here I am using combination, right? Two lenses. Okay, so here we use power of combinations. For example, so that is P is equals to P1 plus P2. Here I am using two lenses, right? Okay. When you add power of this lens plus power of this lens, then you will get the total power of these two lenses are combination. Okay. For that we have formula P equal to P1 plus P2 plus P3 plus and so on. If you use two lenses, then we will write the formula like this: P equal to P1 plus P2. Mean here I have used two lenses, so power of this lens and power of this lens. Suppose if you have three lenses, at that time P is equals to P1 plus P2 plus P3. Okay. Yes. So now we will discuss some problems related to power of a lens. Okay. See here. First one. Find the power of a concave lens. Concave lens of focal length 2 meter. Of focal length 2 meter. Okay. See here. So find the power of a concave lens. So here clearly they have mentioned a concave lens. Okay. So here you should know. So you will at the end you will get the answer, right? And that answer it should be in negative. Why? Because here they have mentioned the lens used is concave. If it is concave, then you should get that power of lens in negative. If it is convex, then you should get that value in positive. Okay, so find the power of a concave lens of a focal length 2 meter. Yes, we know the formula. Find the power of a concave length. So we know the formula, that is P equal to 1 by F. So what is the focal length here? So focal length is minus 2 meter because it is concave lens. Okay, now substitute here. So that is 1 by F here is minus 2. Okay, so that is minus. See, half means minus 0.5 meter. Sorry, minus 0. Alright, minus 0.5 diameter. So P is equals to minus 0.5 diameter. Then what is the meaning of this 0.5 D? You know, what is the meaning of 2D and what is the meaning of 3D? So we can say that 2 diameter and this is 3 diameter. Then what is the meaning? See here, suppose if the focal, see you have one lens. You have one lens. The focal length of this lens is equal to say 1 meter. Okay. Now focal length of this lens is 1 meter. So then we can say that this power, the power of this lens is 1 diameter. Okay, 1 diameter. If the focal length is see, if the focal length is 2 meter, then we can say that power is 0.5 diameter. So clearly, what is the meaning of 2 diameter or 3 diameter? Okay, so 1 diameter means if the focal length of the lens is equal to 1 meter, then power of that lens is 1 diameter. Okay, so maybe they will ask define a 1D. At that time, you should know what is the answer for that one. Okay, so 1D means the power of a lens is equal to, sorry, 1D means the focal length of lens is equal to 1 meter. Okay. Here, find the focal length lens of power minus 2.0D. What type of lens is it? What type of lens? What type of lens? This, okay? Yes, here. Find the focal length of a lens of power minus 2.0D and what type of lens is it? So what type of lens is this one? Because I have told, right, if the power, if it is in positive, then it is convex lens. If it is negative, then it is concave lens. So now the power, it is in negative, right? The power is negative, okay? Negative minus 2.0D. So clearly we can say that the lens is concave lens. So now here find the focal length. Okay. So here they have given power is equals to minus 2.0D. Yes, we know the formula to calculate the focal length. P equal to 1 by F. P is equals to 1 by F. We need F, right? So bring F this side, P this side. Okay. So that is F equal to 1 by P. And F is equals to what is P? P is minus 2. So 1 by 2, what is the answer? So that is equal to minus 0.5 meter. Okay? Minus 0.5 meter. Next one. Yes, now see here. Doctor has prescribed a corrective lens of power plus 1.5D. Okay, find the focal length of the lens. So here we have given power. The power is plus 1.5D. Okay, is the prescribed lens diverging or converging? So diverging means concave, and converging lens means convex. Convex. Okay, so now the power is in positive, right? So power of lens is plus 1.5. So clearly we can say that prescribed lens is converging, okay, or convex lens. Okay. Now calculate the focal length. So we have given power P equal to plus 1.5d plus 1.5d. So we know the formula P equal to 1 by f, or that is f equal to 1 by p. Okay. Now f equal to substitute the value. So 1 by what is p? That is 1.5. Okay. So better into 10 and divided by 10. So we'll get f equal to 10 by 15. 10 is equals to, sorry, f is equals to 10 by 15. Okay. The answer is equal to 0.66 meter. Okay. So focal length of that lens is equal to 0.8 meter. So next one. Two thin lenses of power plus 3.5d and minus 2.5d are placed in contact find the power and focal length, and the power and focal length of the lens combination. Okay. See here two thin lenses of power plus 3.5d and minus 2.5d are placed in contact. Okay, here they are used two lenses. So one is convex and another one is concave. Okay, so find the power and focal length find the power and focal length of the lens combination. Okay, find the power and focal length of the lens combination. Here we don't want individual focal length and power, so we need the power of the lens combination and focal length. Okay, yes. Now here right, we know the right formula, the combination of lenses. Okay, so that is P equal to P1 plus P2 plus P3 and so on. So here we have used two lenses, right? So we can write P equal to P1 plus P2. What is P1 value? So I will take P1 as plus 3.5D and P2 as minus 2.5D. Okay, now substitute here. P1 is 3.5D and this is minus 2.5D. So what is the answer? So answer is equal to, this is plus 3.5, right? So plus 1D. Plus 1D. So power of power of the lens combination, that is equal to 1D. Next, find the focal length. Yes, power equal to 1 plus D, right? So then we know the formula P equal to 1 by F. Then it is F equal to 1 by P. So what is P value? P value is 1D. Okay. So then F equal to 1 meter. Okay. So focal length of the lens combination, that is 1 meter. Okay. See, this focal length is the what? Combination of the lenses, not individual. Okay. Here they have used two lenses, but this focal length is the combination of lenses. Okay. Yes. Yes. So now we will discuss some problems related to refractive index. Okay. The refractive index of flint glass, the refractive index of flint glass is 1.65. What is the speed of light? What is the speed of light? What is the speed of light in this glass? So given speed of light in air is 3 into 10 raised to the power 8 meter per second. Okay. The refractive index of a flint glass is 1.65. what is the speed of light in this glass? Given speed of light in air is 3 into 10 raised to the power 8. Okay, so you know, right? If one of the medium is air or vacuum, then to calculate refractive index of that medium, we have a formula, that is Nm is equals to C by V. Here Nm is refractive index of the medium. So here which medium? That is glass. And what about C? C is the speed of light in air or vacuum? Here air, right? So that's why C is the speed of light in air. Then what about V? V is the speed of light in medium. That is flint glass medium. Okay? Yes. First write the given data. So what is this 1.65? This 1.65 is the refractive index of flint glass, right? So now I will write Nm is equals to 1.65. It has no unit. Okay? Refractive index, it has no unit. See, what is the meaning of 16.5? We'll see later. Now, what is the speed of light in this glass? So here we need V. So we need V. We know C value, right? That C value is equals to 3 into 10 raised to the power 8 meter per second. Okay, so now bring me this cell. So we can write this as V equal to Nm. So C value 3 into 10 raised to the power 8 divided by 1.65. So better here into 100 and divided by 100. Okay, so you will get 300 into 10 raised to the power 8 divided by 165. 165. So what is the answer? So right here, V is equals to 1.85 into 10 raised to the power 8 meter per second. Okay, 1.8, sorry, 82. 82 into 10 raised to the power 8 meter per second. So now here air is a rarer medium and flint glass is a denser medium. Okay, you know, in air medium the speed of light is 3 into 10 raised to the power 8 meter per second, but here the speed of light is 1.82. So here the speed of light, okay, reduced. Here the speed of light reduced. Why? Because flint glass is a denser medium, so that's why its speed reduced to 1.82 into 10 raised to the power 8 meter per second. Then what is the meaning of this 1.65? Already I have told, right, while discussing the refractive index. Okay, see here. So I will write speed of light in air. Then this is speed of light in glass, inside the flint glass. Okay. So now what is the speed of light in air? Speed of light in air is 3 into 10 raised to the power 8 meter per second. What is the speed of light in flint glass? See here, we obtained 1.8 into 10 raised to the power 8 meter per second. Okay. Now see here, now these two values are not equal. Correct? Because this is 3 and this is 1.82. So 3 is greater than 1.2 and here also 10 raised to the power 8 and there also 10 raised to the power 8. Okay. So don't worry about these two. But here 3 into, here 3 is there, here 1.82 is there. So clearly we get that, so these two values are not equal. Now if you multiply 1.65 to this value, so then you will get the 3.3, right? So now we can say that these two values are equal. Correct? So here we won't get exact 3, but that value is approximately almost equal to 3 only. Okay. So now here these two values are equal, right? So when you multiply this 1.3 to the speed of light in flint glass, then this speed is equal to the speed of light in air. Okay. So here you have to multiply this 1.65. So which means See here, the speed of light in air, is 1.65 times greater than the speed of light in flint glass. Okay, so meaning of that 1.65, the refractive index of flint glass is 1.65. So we can say that meaning of that that statement, the speed of light in air is 1.6 times greater than the speed of light in flint glass, or we can say that the speed of light in flint glass, is 1.6 times slower than the speed of light in air. Okay, so speed of light in flint glass is 1.6 times, okay, slower than the speed of light in air. Clear, right? So here 1.6 times the speed of light is slower in flint glass compared to speed of light in air. So this is the meaning. Okay. Next. Velocity of light in a medium is 1.8 1.5 to 10 raised to power 8 meter per second. Find its absolute refractive index. Okay, find its absolute refractive index. See here, velocity of light in a medium. Okay, so we don't know which medium it is, so I'll take that as nm equal to 1.5 into 10 raised to the power 8 meter per second. Find its absolute refractive index. Sorry, this is the speed, right? Speed of light. So v equal to. So we need nm. Okay. We know the formula for absolute refractive index. Nm equal to c by v. So c means what? Speed of light in air or vacuum. So that is equal to 3 into 10 raised to the power 8 meter per second. So we need refractive index, absolute refractive index, right? Absolute refractive index. The formula is already arranged. So see, 3 into 10 raised to the power 8 meter per second divided by what is v value? That is 1.5 into 10 raised to the power 8 meter per second. Okay, so meter per meter cancel, 10 raised to 8, 10 by 8 cancel. Okay, 3.51 sir, and this is 2 sir. So nm is equals to 2. Remember, it has no unit. Okay, yes. So now here refractive index of that medium is 2. So what is the meaning? Okay, so here we can say that the speed of light in this medium is 2 times slower than the speed of light in air or vacuum. Here 2 times the speed of light is reduced. Okay, 2 times reduced compared to air or vacuum. Or we can say that speed of light in air or vacuum is 2 times greater than the speed of light in this medium. Okay, the speed of light in air or vacuum, because here we don't know, right? the ray of light travel from medium to air or vacuum. Okay, but they are asked to find its absolute refractive index. So that's why better you can take air. So the speed of light in air is 2 times greater than the speed of light in this medium. Okay, so this is the meaning of refractive index. Okay. See, so now this is a homework for you. An object of height 6 cm is placed at a distance of 20 cm in front of a concave lens of power -8 diopter. Find the size of the image. Okay. This is a homework for you. Find the solution for this question and put that solution in your WhatsApp group. Okay. So successfully we have completed this chapter. Okay, so I will stop here. Tomorrow I will continue the class. Thank you.